In lesson 4, we're going to focus on the equation of a line in slope-intercept form. So instead of having to plot random points and connect them to create a line, we're going to look at how can we use the equation of a line in slope-intercept form to help us come up with the graph. So the first thing you have to understand is what is an equation of a line in slope-intercept form. And what that is y equals mx plus b. This is something you've heard of before, you've used all the time. Y equals mx plus b is the equation of a line in slope-intercept form. The reason why we call it slope-intercept form is because when that equation is in the form y equals mx plus b, we have the slope visible, which is the number in front of x, and then we have the y-intercept visible, which is the number at the end. So if you look at this first example, if we want to write a line that has a slope of 3/2 and a y-intercept of 1, the easiest way to do this is to write the equation in the form y equals mx plus b, replace m with whatever the slope is, which is 3/2, and then b is just plus 1. That's the y-intercept. So that's it. So let's look at another example. First thing for this one says find the equation of the line with the slope -4/3 and a y-intercept of 5. Then we're going to use that information to graph the line. So first thing is we're going to use y equals mx plus b to do this. I'm going to plug in the slope. So this is the m value. So -4/3 x plus my b value, which is the y-intercept. So it's a +5, so it's going to be a +5 at the end. So there's my equation. And now the question is, instead of using my table, my x and y table, and plotting just any points I want, I can use the y-intercept and I can use the slope to help me graph. So the y-intercept is always going to be your starting position. So the y-intercept is useful because it tells you where to start. It's your starting point. So that means I'm going to go to the y-axis and I'm going to start at 5. And then the -4/3, which is your slope, tells you how to move. So this is how to move, or how to travel. So that means I need to move down 4 since it's a -4, and we always are going to move to the right to start. So we're going to go over to my graph, and I'm going to go down 4, so 1, 2, 3, 4, and then to the right 3, 1, 2, 3. And then I'm going to repeat the process. Down 1, 2, 3, 4. Right 1, 2, 3. And then what you're going to do is you're going to connect those points. And then we're going to put our arrows on. We're going to put our equation on so that we're fully complete. And this was y equals -4/3 x plus 5. Keep in mind too that -4/3, the negative can be up top with the 4, it can be negative down with the 3, or it can be out in front. But regardless, you always want that negative really to go with the top value when you're thinking about slope, because that's going to tell us that we have to move down if it's a negative. And we don't want a negative down with the 3 because we're always going to move to the right with the 3. So if you ever have a negative, you really want to think of it being as up top, even though all 3 fractions would be equivalent. -4/3, a -4 over +3, or a +4 over -3. It's all the same thing, but when you're doing slope, always put the negative up top. So let's look at another example. We have this equation here, and I want to figure out the slope and the y-intercept. Well, if you look, it's not in y equals mx plus b form, this equation. So my first thing that I need to do is I need to get this into y equals mx plus b form, because in order to find the slope and the y-intercept, I need it to be y equals mx plus b. So I'm going to take my equation, And it's actually something that we learned in the last unit. You're just going to solve it for y. So bring the 2x over, and we have y equals -4 plus 2x. Now, one thing I want to show you is that this is still not in y equals mx plus b form. So that means I have to bring that 2x in front and then the -4 at the end. You don't have to show this step right here. You could have just taken and said, well, I got canceled out those, and then I know that my x has to come first, so it's y equals 2x minus 4. You could have just done it that way. So now that it's in y equals mx plus b form, I can pull out the slope. So my slope is really 2 over 1, since any whole number can be written as a fraction by putting it over 1, which really means it's positive, so it means up 2 and right 1, because we're always going to go to the right. And then your y-intercept, pay attention to the negative sign, is going to be -4. Because you got to keep that sign. So I'm going to -4 on the y-axis, and then I'm going to count using my slope, rise 2, run 1, up 2, right 1, up 2, right 1, up 2, right 1. And you can just keep going and you get several points. Keep in mind, if you start plotting points to the right and you want to then do some points on the left, you just do the opposite. So if I went right up to right 1, I'd be going down to left 1 if you wanted to come up with some points. So just keep that in mind, that that's possible to do that. But always go to the right first and then just backtrack to get the others. Okay, so then we can draw our arrows and write our equation. So -2x plus y equals -4. All right, let's look at another example. What happens if I want to write the equation, but they don't give me the y-intercept and the slope? So you still need to know those two things, but this time you're going to have to find them. Because if you ever want to write the equation of a line, at this point, we need to know the y-intercept and we need to know the slope. So what we're going to do is we're going to figure those things out. Well, we know the y-intercept is where the line crosses the y-axis. So the y-intercept is actually equal to 0, 1 in this particular case, which really means that b is equal to 1, because the coordinate is 0, 1, but the y-intercept is actually 1. The b value is 1. And then to figure out the slope, we need to figure out another point so that we can count the rise over the run. So if I look, I see that I have another point right here that's landing on an x and y value that are both whole numbers. So I can use that as my way to count. So in this case, I'm looking at my rise over run, which is really going down first when I start at this red point. I went down 1, 2, 3, and then I had to run to the right 2. So that means my slope was down 3, right 2. And since you went down 3, that really means it's a -3 over 2. So that tells me my m value is -3 over 2. So now we just plug these things in. So slope is -3 over 2. And then my y-intercept was a +1. So that's it. And then one last example here, same kind of idea. Notice they give us actual points. So I want to show you how to do this kind of using the formula, using the slope formula. So again, you want to write the equation. So y equals mx plus b. So we need to replace the slope and the y-intercept. The y-intercept is sticking out right here. I see it as 0, 3. And I'm going to find the slope. So you can find the slope, remember, by counting or by using your formula. I want to show you this one using the formula since they state the two coordinates. However, you could always just graph it as well or count on the graph. So remember the slope formula though is the change in y's over the change in x's. So that means I'm going to plug in my y values. So 3 minus 0. And then my x values. So then it's going to be in the same order. So I took the top coordinate. So 0 minus -2, which gives me 3 over 2. So then I can plug those values in. So 3 over 2x plus 3 for my y-intercept. And then that would be my equation. Now keep in mind, I could have also went on my graph here and I could have just counted, which, you know, that's totally fine to do it. I just wanted to show you a different way. So you could have said, okay, well, I started at the leftmost point. How much did I rise? So I had to go up 1, 2, 3, and then I had to go right 1, 2. So again, rise over run would have been 3 over 2. So that's another way of doing it. So that's it for using slope-intercept form to find the equation of a line. In the next video, we'll look at a different form, which is called point-slope form.